All right, I think we are live. Today, we're going to have some fun. We're not going to do Final Fantasy VII. Let's keep it a little bit different. We're going to get back to programming, which is what I used to stream. And today, I am programming a debugger, which we're going to see real quick. Debugger that I am working on. It's building real quick. This is a native C++ debugger. What shall we? Okay, it's in the very beginning stages here. So yes, the UI looks like Windows 3.0, but it's meant to replace basically everything in Visual Studio. And today, the thing that we're going to do is this task right here, which I've added for myself. Current behavior, sometimes the save checkpoint button is disabled while running. Other times it is enabled. If the button is pressed while the hosted app is running, it waits until the next time the hosted app is paused, then saves the checkpoint. That's describing the current behavior. If the button is pressed while the hosted app is paused and the user runs and then presses restore checkpoint while running, sometimes it works, but usually you get a bunch of errors. So we're going to fix that situation. Here's what it should do. Save checkpoint is always enabled. If the user presses it while the app is running, this debugger stores a checkpoint as soon as possible wherever the host happens to be, and the hosted app continues running. No matter whether the checkpoint was saved while the host was running or not, restore checkpoint results in the checkpoint being restored and the hosted app paused at the checkpoint. So if that didn't make any sense to you, let's review what checkpoints do in Lux. You click Save Checkpoint. Then it puts a checkpoint in the log and it marks where you saved that checkpoint, and then you can continue your program like normal. I'm stepping into this recursive function a few more times. And then whenever you're done, you can click this button, Restore Checkpoint, or you can click here and you can see what the original, see I have 2 invocations of F here. But in the actual program, I have 5 invocations of F because I've walked into this recursive function a little bit. So you can say restore checkpoint and it brings me back to 2 invocations of F. And then we're keeping going here. Just like before. Okay, so that is checkpoints. Oh my god, I just realized something. I just realized I have a bug in my implementation of checkpoints other than the bugs that I just talked about. Let's see here. Debug thread. So this is all of the bare bones information that the debugger itself stores. And I'm thinking, how much of this stuff do I have to stash away? So the checkpoints works by when you press the save checkpoint button, it doesn't actually do anything. But then it captures all memory accesses, and it does save off the stack, it saves off the registers, the context, but it doesn't actually do anything else. And so I'm thinking maybe I have to save off a bunch of this stuff too. Do I have to save none of this? Stack data. Oh, I'm going through this real quick. I think maybe I might have to save off. Where is it? Like this guy? I'm just gonna make a note to myself later because I think I just witnessed some buggy behavior here. I'm gonna restart it. I'm gonna restart the debugger and see whether I can repro this bug that I just found, and then we'll make a note of that, and then we'll continue on to actually coding the debugger. So if I hit F11 here, save checkpoint, then I F10 a few times. Okay, now restore checkpoint, and F10 a few times. No, it stepped out, as it should have. Okay, weird. Let me try that again. I'm gonna try and repro this bug. The bug that I noticed was I would step in F11. Okay, I saved the checkpoint, And then I was trying to step over right here, step over, and it stepped me in instead. It appears I can't repro it anymore. And I'm wondering whether there was some state in the debugger. Debugger state. There is literally, I don't even remember what that is. There's literally a variable of type debugger state. Yeah. This guy right here. Like, I'm wondering whether the debugger thought I was still stepping in because that's what I was doing when I saved the breakpoint. I don't know. Anyway. Well, that'll have to be a bug for another day. What we're doing right now is handling the case where the debugger is running. Do I have here? Do I have here? I forgot to actually pull up my stream so that I can see whether chat is going. Let me do that real quick. Okay, forgive me if you've asked a question between now and the beginning of the stream. Please ask it again. I'm more than happy to answer any questions. So I'll be watching chat from here on. Yeah, so what I have to do here is if I press the save checkpoint while the application is running, the wrong thing happens. So that's the problem that we're going to try and solve today. I think I can't actually solve it with any of the... Oh, I can. So Hanoi is my Towers of Hanoi test program, and if I make 130 towers, then it takes so long to actually run Hanoi that I can do it. Okay, so here's the first example. Save checkpoint is not enabled, even though... All right, now it is enabled. If I get rid of this and run it again, and it disables again. Yeah. So the first stop is, like the website says, save checkpoint should always be available. So let's do it. Save checkpoint. So I'm gonna have to find my UI. Where's my UI? Debugger screen. Save checkpoint. Everything is very rudimentary still in this project. Set enabled. It is enabled if I am debugging and I am paused. Okay, well, I don't want to, I want to show it whether it's paused or not, but I think I actually don't want to show it if the debugger is not running. Do I want to do that? If you press save checkpoint while the debugger is not running, is that something that the user would expect you to do? It doesn't really make any sense. Save checkpoint while the program's not running, that's like the checkpoint. You're saving the program not running. Restore checkpoint would close the program. But it's possible that the user thinks that save checkpoint when the program isn't running is like saving a checkpoint right before the main function of your program starts. So I shouldn't break that expectation. I don't think that is an actual expectation, though. I think I'm fine. If anyone gives me feedback, then I'll change that. So this is maybe a misnomer right here. It shouldn't say the save checkpoint button is always enabled. I'll go ahead and edit it for myself. Is always enabled if the hosted app is running. You get what I mean. Okay, so I think we just accomplished that actually. So easy. Step 1, done. Okay, fine. If the user presses save checkpoint while the app is running, the debugger stores a checkpoint as soon as possible wherever the host happens to be. So right now, let's see how checkpoint works. Save checkpoint, Save checkpoint gets called, which does all this stuff. But I think actually, checkpoint. This is the inner loop of the debugger, check for messages. The way this debugger works is every 100 milliseconds, which is an eternity to a computer, 100 milliseconds. It's 10 times a second. The debugger will interrupt itself. Like, even if the program's just running normally, the debugger will interrupt that program and say, hey, I have some things that I want to... It's the opportunity for it to check for messages from the UI, all that sort of thing. Forward, like, right now the debugger captures the input and output, standard input and output that would normally go to the console. It captures that. So it's like flushing buffers, checking for messages 10 times a second. And during that time, the program is paused. So here's what we're going to do. We're going to run the debugger. Right now, I realize this is ironic, but right now I'm using Visual Studio to build the Visual Studio debugger to build my debugger. Just because my debugger's not ready. But as soon as possible, I do want to switch over to using Lux to debug Lux. Anyway, so we're going to click load here. We're going to click run. No, I want to set a breakpoint. Debug thread. Save checkpoint. We're going to, wait. We want to set a breakpoint right here, basically. I'm ready to set the breakpoint, and it's running. I set it. All right, so now we've caught it during one of those times where it wakes up every 10 milliseconds. So, oh good, we are going to check for messages during that time. Okay. Oh, but here's the kicker. If we're running, we have some slightly different logic. Is that okay? Oh, just because we want to do the non-blocking. Okay, that's fine. So that means I think we can put a breakpoint right there. Save checkpoint. And press F5. Go press that save checkpoint button. Okay, here we are. So now we're saving a checkpoint while the program is running. Debugger state is running. That means we're going to save the checkpoint. Okay, we do all this stuff. All this should work fine because the guest program is now paused. Should all work fine. Sends the checkpoint info. App is still running. No other messages. So we send stack data. Uh-oh. Checkpoint creation frame not found. Interesting. Set checkpoint info. So the debug thread sends info. Really? So the debug thread, when you set a checkpoint, sends info to the UI about the checkpoint that was just set. And it should all be here in this stack capture object. So stack capture has some of the memory some of the contents of memory, not all of it, but it just has like just a little part of the stack. I think just 4K of the stack. Yeah. So there's like a big buffer containing a bunch of memory. And it has the 4 thread stacks, which is the one main stack, which is just a bunch of Hanoi. And then 3 stacks that are automatically created, 3 threads that are automatically created by the operating system. I think it's just the thread pool, the standard library thread pool or something like that. In any case, that would explain it. Stack frame -1. So some invalid data was sent via set checkpoint info. So where was that? So right here we send set checkpoint info. This stack capture is wrong. Oh, probably because the stopped at isn't set at this point. So let's do this. Oh, we're gonna have to restart. The debugger died. Run Hanoi. Press save checkpoint. Get to that point. So normally this is just like a convenient variable that is set. Let me see. I'm stopped at. Here we go. It is set in this set debug event info procedure. And then it's just a convenient variable that can be used in other places. It's set every time the debugger stops anywhere, and then I can use it from other places. But it appears that it hasn't been set this time, and that's actually because even though the debugger was stopped, it wasn't like officially stopped. It wasn't stopped for a legitimate reason. It was just temporarily stopped because I do that periodic stopping. So I need to find a way to set this variable even though the debugger hasn't stopped for real. So I could just say I'm always gonna set it even if I'm only temporarily stopped. Find thread stack. The question is like, how expensive is this guy to do? I probably don't want to do this. I mean, I don't think I'm ever going to have this many threads, but do I want to do it 10 times a second? Do I want to call this function 10 times a second is my question. Should be fine. How many threads doesn't, like, what's the maximum number of threads? Number of useful threads to have is bounded by processor cores. And you're not really ever, like, you can have a bunch of extra threads. They're mostly going to be blocked. But I don't think you're ever going to have more than like 100 threads in one application. I don't think that's like a thing. If you do, I might start getting some performance problems here. But I'm just going to, yeah, I don't think that's a thing. I'm going to ignore that problem. Okay, so send debug event info. So we're just going to take all of this. Yeah, all of this. And yeah. What is this? Restore checkpoint. Yeah, fair. Okay, and we're going to put it in. Just know my way around my own program here. We're going to put it right here, right after we get out of wait for debug event, the API function. So I think we put it here, yeah. Boom. Wait, can we put it there? No, because this isn't the only time we call wait for debug event. Yeah, we call it a bunch. Oh, crap. Forward pipes to UI. Okay, so here's what we have to send. When does this get called? Step over. It mostly gets called at the ends of things. Yeah, because it's sending information back to the UI about what happened. Oh, and it requires the stack data to be set. Relax, bud, relax. It requires the stack data to already be set. And when is the stack data set? Calculate stack data. When is calculate stack data set? calculate stack data. Calculate stack data, send stack data, and okay, various other times. Calculate stack data. Okay. Well, then the next question, I guess, is do I have the stack data at the time when I need to use this stopdat information? Save checkpoint. So I haven't calculated stack data here. It appears the answer is no. No, yes, the answer is yes. So you know what, maybe what I do is stopdat. Maybe I have like a calculate stop location. I make like a function that calculates all of this stuff, and it calls calculate stack data or something like that. It's not that expensive to calculate. Wait, stack data is expensive to calculate, and I don't want to do it 10 times a second. I think that has a real chance of slowing the app down. So we're not going to do that. Okay, here's what we do. Send debug event info. We're just going to do the same pattern that we do here. That's calculate stack data. Okay. We're also going to do stopdat is frame data. Frame data. Calculate frame data. Okay. Frame data. Does this actually set stack data? Yes. I don't like that it does that. It should just return it and not. Yeah, that's bad. I want to clear that up too. And I don't like that this function calculates stack data, also implicitly changes state. That's maybe unexpected behavior. Calculate stack data should, like the person who calls calculate stack data should be deciding whether to do that, I think. Yeah. Yes, I agree with that assessment. So here's what we're going to do. Where were we? We're going to solve that problem in a second. Not solving that problem right now. Calculate stack data. Calculate frame data. So mstopdata. Use calculate frame data. Good. And frame data result equals a new frame data. Boom. Requires stack data to be calculated. Oh, let's do this. Let's do this. Const stack data, stack data. I'm gonna pass that one in. Where's my calculate frame data requires? So it's saying like use this stack data that you previously calculated instead of assuming the stack data in this variable. All right. Good. Good. And we have to write a return statement. So let's do that. Return result. And we good. Calculate frame data. And now we can do this. Stack data. Calculate frame data, stack data. Good. And now I can do this. where's my save checkpoint? Wait, save checkpoint. And at the bottom, instead of using the cached data, calculate it. Cool. And I have an error. Thread ID undeclared identifier. Oh, we just have to find the current thread ID. Wait. Oh, I guess we have to say which thread are we calculating the frame data for. Wait, why do we need that? Stack data. What's a stack data? No, it's over here. It's a vector of stacks. Why do we need that? Why do we need that? Oh, because we're, okay. Calculate frame data for which thread. And so we have to say which frame and the thread. Okay, fine. So we'll do this. So we have to say which frame in the thread we're calculating frame data for. Frame data is, does that make sense? Frame data is, where'd frame data go? Frame data is a process, a thread, and a stack. So basically it's a unique address for a particular stack frame. It's saying which process, which thread, which stack is the current one. Or is anyone. You can refer to any stack in any program using this. So this is saying process data. Okay, so this is what I should do. Stack data. Yeah, I changed my mind about the whole definition of this function. So here's what we're going to do. UN32T process ID. So process ID, thread ID, UN32 stack ID. What do I call it? So what we're going to stack frame. What we're going to do is, and this can be -1. And I think I'll put this at the beginning actually. So we're going to say the purpose of this function is here's a bunch of stack data. This will probably just be a redundant parameter. That stack data should match this process. Pick this thread from it and give me this stack frame and give me a frame data object that matches all of that. So that's going to be what we do here. We're going to do that. Put this here. Okay. So this goes into the caller. Process ID is now, hello. Process ID is now passed in. We use stack data, and now I like this because actually I can make calculate frame data const. Calculate frame data, I'm pretty sure is const now. It doesn't rely on any state, which is good. I dislike relying on state. Will we be able to do the same thing for calculate stack data? Because we'll get rid of... no. Looks like the answer is no. Maybe yes, actually. Maybe yes. That would be really nice. That would be really nice. It'd be really nice to have this function const, because const functions are easier to think about. Okay. Oh, there's one last thing we have to do here. I want to make it so that this stack frame can default to -1. And if you do so, then you automatically get the last stack frame. Okay. And we'll do that. If stack frame is less than 0, else result.m stack frame equals stack frame. Wait, we should still do this. Assert result.m stack frame. Oh, wait, I have to do this. Minus plus stack frame. There we go. So if it's -1, it will add -1 to the size. Okay, so then I still have to do assert stack frame is greater than or equal to 0, and result.m stack frame is less than current thread stack dot size arrow. No, current thread stack arrow m stack frames dot size. Stack frame ID not with it. Stack frame not within thread stack size. So let's do stack frame D not within stack size D, and then we will stack frame current thread stack m stack frames dot size. Good. We wrote an assert. Okay. Okay, now we can calculate frame data here, and we can calculate framed, where else do I do it? Calculate frame data there. Although up here we still have to do this. Okay. Is this available? Processed it? It has to be. Yeah, that never changes. That's set as soon as the application starts up. Okay, good. We're good. We're good. Oh no, thread ID undeclared is still undeclared identifier. Of course it is, because, oh right. Oh no. Oh no, oh no. So, I did not realize that in the case where the debugger is paused, the thread that the user is looking at is like the thread ID. But otherwise, there's not necessarily a valid thread here. Like if the program's running, then we don't necessarily have like a thread that we saved the checkpoint at, right? Anything could have been happening. So, oh man, what do I do? Do I use like the last thread? Do I use the last thread the user was looking at? Do I use just, I don't pick like a random thread. Okay, I think what I have to do, okay. Here's what I have to do. This also defaults to 0. All right, we get rid of this guy right here. We have a default. Yeah, oh, oops. We have a default where if the thread is not running, I'm sorry, where if it doesn't specify a thread here, then if thread ID equals 0, then we put some special values in here. What we're going to do is, if you save a checkpoint while the application is running, then it will just say thread ID equals 0, result.m thread ID equals 0, and result.m stack, man, I keep missing period, stack frame equals -1, which is basically the same information that we had before. And when we restore it, we'll just pick a random thread, I guess, to show the user. I don't know. I don't really know what I'm gonna do there. I don't really think it matters that much. Save checkpoint. We still have to. Oh, you know what? I can't do this. I still have to say thread ID here because there are two cases here. Thread ID. One is that you press save while the program is running, but the other is that you press save while the program is paused, in which case we're going to pass a thread ID into the save checkpoint function, which is the thread that we're currently paused at, that the user is looking at. Thread ID. Save check. There it is. So save checkpoint at this thread ID. So now we have to update everywhere where we save a checkpoint to say stop it at this thread ID right here. Save checkpoint. Oh, do we have this here? Uh-oh. Oh, no, this is where we have to use the default. Okay, I'll come back to that. Save check. Oh, that's the only other invocation. Okay, so save checkpoint, thread ID equals 0. Good. So we preserve the functionality if you have the debugger paused. So far, so good. Okay. That will still crash though, because here we go. Run. Save checkpoint. Now the UI is going to say, hey, you passed me an invalid thread ID and I couldn't find a frame. So we ran into this error just a short time ago. The error is still valid. Let's see, what are we doing with this data? We have to get a source location. Okay, well, we don't have a source location. The UI basically now has to make up, if you can't find a checkpoint creation frame, you have to like make up a source location or something like that. Set checkpoint info. Man, this is rough. Do we know what the... I think I should just default to the main thread. That's what I should do. If there's only one thread in the program, that's obvious. Default to it. There should be two components here. If the program has previously stopped in any thread, it should show that thread. Otherwise, it should show the main thread, which is guaranteed to exist. While the hosted app restores checkpoint as soon as possible, no matter where the checkpoint was saved, while the restored checkpoint results in the checkpoint being restored in the hosted app paused at the checkpoint. Yeah. That's what I need to do. And that's going to be rough because there are two parts there. Okay, I'm going to write those parts here. Okay. If the app has previous, if the checkpoint was saved while the app was running, and the checkpoint was saved while the app was running, and the app has previously been paused. Restoring the checkpoint will show the previously paused thread. Is strike through an option here? Hello? No. Not many options up there. Otherwise, it will show the main thread. Yeah, okay, I'm just going to keep that here, and then I'll remember to do it. I'm not going to do it for now. For now, what I'm going to do is checkpoint location is main, get source location of main procedure. What do I show? I'm just going to show like nothing. Do I even have to set m checkpoint location? Where is it used? M checkpoint location. Get current checkpoint source location. Yeah, it's just for drawing this little label, so I'm going to do this. I'm going to do this. Debug engine. Wait, where are we? If, so we turn this assert into an if. It's now legal not to have a checkpoint creation frame. If we don't have one, we just stick a fake one in there. For now. For now. Okay, now if we run our test program, save checkpoint. Cool. Restore checkpoint. Well, we got a little farther. What did it die on? Set debug. Yeah. Yep. That sounds fine. So, set debug event info. It doesn't. Set debug event info. Yeah, same thing as before. It doesn't know what to do with that. Okay, well, let me. So as we're restoring, I think we see that we don't have a stack frame to restore at, because the app's never really been pointed at anything. So let's see. Send debug info. Yeah, this won't have a thread ID in it. Actually, I think this is wrong. Because if I save a checkpoint debugging thread A and then switch over to thread B and then start doing things in thread B, it will send debug info for thread B when I restore the checkpoint instead of thread A. And I really should go back to thread A. This should be like save checkpoint on this thread. So we should save which thread the user was looking at as a part of the checkpoint. Yeah, it's like we should have a copy of frame data right down here. We should say checkpoint frame possible to be not valid if the checkpoint was made while running. This is what we're going to do. Now we go to debug thread, save checkpoint. And we save that checkpoint frame. mCheckpoint frame equals calculates frame data. Boom. Now when we restore the checkpoint, we use that. We use the checkpoint frame. This is now correct behavior. And now send debug event info needs to be able to handle invalid thread ID. Thread ID 0, yep, this should be fine. It will generate this guy, and then that will be sent over, and then now we're here. So debug engine 175. So the thing that we changed is that it's now possible to send an invalid frame back over to the UI. So it's possible for this to be null. If this ends up being a invalid thread ID or 0. What do I do in that instance? So what am I trying to do? This guy right here, I'm just trying to find the stack frame. Wait, why don't I use the... Oh, it's... Okay, it's trying to handle a different feature here. I don't even support that feature right now. I removed this feature, so I'm just going to leave that there. So this code effectively does nothing. I believe this will break immediately out of this loop. Okay. So stack frame will just be... Wait a minute. Yeah, this means that I'm ignoring the stack frame that I send back to the UI. I should do this. I should do this. Whoops. Yeah. Okay. I think we're good now. Stack frame. Yeah. Oops. Okay, anyway, what was I doing? I probably just introduced a bug, but it's okay. I have tests. So we're just finding the stack frame, and then we... okay, so in other words, I don't need to do any of this unless I actually have a valid thread ID. So, if current thread stack is a valid object, then you can do all this mess right here, which is really just like trying to correct the stack frame for if this feature is present, which it's not right now, but I'm just going to leave the code as it is. Okay. And actually, you know what? If I'm going to do that, then maybe I should just leave this bug for another day. Oh, I don't know. Okay, I'll leave it. Whatever. Okay. So we're going to skip that crash, and then the program will continue to try and use that frame data to find a valid stack frame. This is going to fail. So it's going to try and pass that source location here. So here's what we have to do. If current stack frame is valid, show the source location, otherwise do nothing. Okay, I think this will be good enough for now. In fact, I might take that bit that I wrote in GitHub and put it in a future task, just to make what I'm doing right now a little bit smaller and reduce the risk to myself that I'm going to break something. Okay. So we're going to run, save checkpoint, restore checkpoint. Bonk. Okay. I see. So the debug thread has decided to send to the UI some debug event info. We say, hey, we have new debug event data. Well, actually, we don't have new debug event data, do we? No, we don't. We don't really. Yeah, maybe I just don't call it in this case. Because I have an invalid frame. I really shouldn't call this if I have an invalid frame. I don't think that makes any sense. What do people do when they get this message? On new debug event data. On new debug event data. Oops. That's not what I want. Oh, there's only one callback in the processes panel. Oh, it expands the stack frame to that. We don't need to do that. I don't want to do that. I'm not going to do that. So only if there's a current stack frame will I okay, then here's what I can do. I can put this assert back. Put all of this in here. There, problem solved. Yeah, we shouldn't call either of these if we don't have a valid stack. It's a bad idea. Keep forgetting to kill the debugger before I actually run it. Long time no see. Thought you disappeared completely. Yeah. I took a very long break. And now I'm back. Thanks for the warm welcome. It's a very long story about why I took a break. Basically, it's like a really, how should I phrase it? Like a really strenuous time in my life for a while. I just couldn't stream and have all that stuff going on at the same time. So I took a pause. Now I'm back. Restore checkpoint. Okay, cool. It worked. Sweet. Yeah. That's a really tall stack. Should be 130 of these. Oh, wow. My scroll bar doesn't work at all. Look at my scroll bar. Oh my god. Yeah, this is totally borked. Anyway, this does seem to work. It is acceptable. The scroll bar is fucked, but restoring the checkpoint basically did what I wanted it to do. I'm going to take this and copy it out to just another task that can be done later. Yeah, we'll prioritize it differently. Oh wait, can I just press this button? Okay, I'm going to do this after the stream. 600p is a bit low, especially when the content has such high frequencies like text. Is that on purpose? No. I basically have no idea what I'm doing when it comes to streaming. So, oh yeah, I see the source is 600p. Can I make it not? Okay, you know what I'll do for the short term until I figure out how to fix that is I think I can just, yeah. Oh man, I wish I had a bigger monitor for sure. Okay, well I'll just have to do single layout until I can figure out. Hopefully that is easier to read. And I'll make note of that for next stream. I'll try to stream at a higher resolution. Maybe you could stream at a bigger monitor too. I don't know what I can do about that in the short term. I do have another monitor over there. I'll think about that later. I'll think about that off stream. Okay. Cool. So now, okay, so this works. This is good. This is good. What else do I have to do on this task? If the user presses save checkpoint while the debugger store, no matter whether the checkpoint is saved while it was running or not, restore checkpoint results in the checkpoint being restored and the hosted app paused at the checkpoint. I think we have all of this now. If the user presses save checkpoint while it is running, debugger stores the checkpoint as soon as possible. Yeah, I think we've done that now. I'm just gonna cycle the debugger and make sure that regular checkpoint still works. Save checkpoint. Oh. It didn't show save checkpoint. It didn't show the little checkpoint line right here, so I've broken that at least. And yeah, this doesn't auto expand to where the checkpoint was. But restoring works fine. Okay. So why doesn't it show save checkpoint? And there's this. Oh yeah, this thread ID is 0. So somewhere zero thread ID is getting propagated around my app. That's no good. That should be a pretty easy thing to find. Oh man, when I have more screen real estate, I put all the headers on the right and the source code on the left, and that helps me a lot. Maybe I shouldn't do this. Maybe I should go back to 2 columns. Otherwise, it's going to drive me crazy. Put all the headers over here. Yeah, you know, I kind of like big letters like this, big font. When the font's so big, I have to do horizontal scrolling and stuff. It's not that big of a deal. Let me clean some things up just to make it easy for myself real quick. Get rid of some stuff. Make this a bit smaller. Make this a bit smaller. Okay, I think. Yeah, all right, that's fine. We got a little screen real estate here. Borderline readable anyway, so don't stress it. Okay, I'm just gonna turn it down one bit. One step bigger than normal is certainly good enough for now. Cool, thanks. All right, so I think actually what I have to do is go to debug thread, save checkpoint. I have to figure out where this 0 thread ID is getting introduced. Oh wait, no, this one works fine. This should be a 0 thread ID. Okay, one more time. Okay, now we're going to save checkpoint. Aha, this should not be a 0 thread ID. Oh, right. Yes, absolutely. So right now, we're paused in the debugger. And so we should have stopped at equals correct thread ID. But if we are running and we click it, then we're not paused, and this is invalid. But if we're running and then we pause, wait, what am I thinking here? And then we start running again, and I save checkpoint, this should be 0. Is it? No, or no. This. Okay, so I can't just use this data blindly. I need to say I guess I can take away the default argument here because I'm going to pass an argument in regardless. Human32 thread ID equals 0. If debugger state equals debugger state paused. If the debugger is paused, then I look up the current thread ID. I think I can just like thread ID equals calculate. Why are these two not? Thread ID equals Huh. How do I get the thread ID? There would have been a break event somewhere, and I need to get the thread ID from that. Calculate frame data, create frame data. Wait a minute. Oh, yeah, this creates a frame data from the stack data. From the debug event. I basically need to know where this is called and use it. Yep. Create frame data, Oh. That's not used in nearly as many places as I thought it would be. Okay. No, you know what I can do? Oh, oops. I modified something else. I have this trick where if I want to go back to where I just was, I use undo, redo, and it moves the cursor back to where I just was, unless I got distracted and modified something else. Okay. We were here. Thread ID is, if I'm paused, I'm just going to use .m thread ID. Yeah, pretty sure I could just use that. Should be fine. Otherwise, I use 0. This will fix it. So this is like stop.thread thread ID is like every time the debugger stops, this stop.dat guy gets filled in. So it will just be sitting around, still probably valid. I don't really like that very much. At some point I need to, like, this code has grown very organically, and I'm not sure that I like some aspects of the structure. And one aspect I don't like is that the stack and thread and all this frame data and all this stuff are calculated on the fly whenever they're needed during the processing that's done after the program pauses. But I wish what would happen is that anytime the program pauses, it's all calculated up front and available throughout the whole rest of the thing. And that way you don't have to like, you'll never accidentally calculate it multiple times or anything like that. I'm not going to do that right now, but that's definitely a thing that I've had in the back of my head that I need to change about this. Okay. Let's compile it, see it run. Okay. Save checkpoint. Thread ID valid. Actually, let's do it again in the case that I was worried about. Save checkpoint. Good. It would have run this. It would have It would have run this. Debugger state was. So it did not use this and thread ID 0. Good. So save checkpoint 0. Okay. Restore checkpoint. Wow. Shouldn't have done that. Oops. What happened there? No, we shouldn't have had a valid stack frame here. Wait, what did I do? I had it running and I restored while I was running. This should have been all... Huh. What did it get? It got this. Okay. And now it's trying to update an entry. So it's filling out this tree here over on the right. And place back with unused. It's like in the middle of doing push back in the debug program here. It's filling out a variable of type. What is your type? What is your type? Integer. Wait, what's the exact error here? Buffer is the wrong size to convert. Buffer is size 8. But T is integer. Okay, why is the buffer size 8? Because we read 8 bytes. Okay, why did we read 8 bytes? What entry is this? What are you? Symbol name is... What? Okay, apparently there's a symbol inside of this vector and place back helper function that stud vector is allocated that is confusing my debugger. I'm not worrying about this now. I'm going to focus on the problem at hand. Okay. One thing at a time, as they say. Save checkpoint. Restore checkpoint. Cool. Nothing blew up. We're here solving the towers of Hanoi with 130 towers, and my scroll bar broken. Everything is broken. Fascinating. Okay, okay. Save checkpoint now, And that works too. Restore checkpoint. Cool. Cool. We're good. We're good. You know what it should actually do? If you... I will also add this to things I'll do later. If you save a checkpoint while running and the app... words. It should show the checkpoint marker in the code panel, even if you save a checkpoint while running. At the appropriate point, even if you save a checkpoint while running. It won't currently do this, so it should. I'm not going to worry about that right now. Proof. We'll do run, save checkpoint, restore checkpoint. This again. Okay, run, save checkpoint, restore checkpoint. So here we are. We're restoring wherever the hell it happened to want to restore. This is where I happened. I pressed save checkpoint wherever the program happened to be. This is where it happened to be. So when I press restore checkpoint, I came here. By definition, it should say checkpoint right there. Right here. And it doesn't. And to prove to you, I'm going to F10 a little bit, F10, and then hit restore checkpoint, and it will bring me back to that same spot. So it should say checkpoint right here, and it's not. But I'm not really going to worry about that right now. Not going to worry about it. Okay. So we know that saving it... Isn't this what I just fixed? No. Why is it stopped at thread ID 0? Interesting. This is way more complicated than I would like it to be. Turns out, debuggers are really complicated. Like, super complicated. In a very pleasant way. I enjoy working through all the complication. Wait, but... What just happened? Calling thread, not owner of critical section. Oh, it was in a critical section. NTDLL, calling thread, not owner of critical section. Owner thread ID. Can I not restore checkpoint if I'm in a critical section? Oh my god. I never considered the interaction of checkpoints in critical sections, and now it appears I must. Which thread was in a critical section? Already, this is actually kind of useful. Hey, I made this feature. And Scott helped, of course. And it is pretty useful. Every time there's a printout to this log, I get to see the thread that printed it out. But it's not showing a critical section, so I don't quite understand this log entry. Okay, another thing to write down for later. Discover the interaction between checkpoints and critical sections. Wow. Okay. Now if I F10, it crashes? It doesn't crash? Hello? Is it going to do something? Is it going to... Oh, it's in this unknown function. I don't know. Wow. Okay. It is in. It was inside a function that I didn't have any symbols for, somehow. Not trying to attack that right now, though. So okay. And now if I F10. Weird. Why was I getting that error before? So what exactly is that? Your project or just a fork where you contributor? So this is my project. This is a debugger, a native C++ debugger that I'm building. It's called Lux. Lux. So it's Visual Studio basically. I'm rebuilding Visual Studio. Let's see here. There are a number of problems I have to deal with. Like why that F10 thing was happening. If I... Okay, let's see. Save checkpoint. Run. Restore checkpoint. And I'm getting an access violation too. That's not good. Two and one. One of the weird things about building a debugger is that you're never quite sure whether the problems you're running into are a bug in your debugger or not. Unsure because you seemed unfamiliar with how stuff was done earlier. Yeah. It's true. Building this thing has been spaced out with trying to figure out how to sell it. And so I sometimes lose track of the implementation because I don't actually spend a lot of time on it. I spend a lot more time on the business end of things, and I have somebody else helping me engineer it. So sometimes I've just forgotten how things were built, or maybe he touched something and I don't recognize it necessarily. But also it's huge and complicated. It's actually not that big and complicated. It's like moderate to small size and super complicated. And so it's really easy to lose track how things internally work. I actually spend a fair amount of time structuring the thing so that I can understand it instead of making progress, because otherwise it will just become unbearably complicated. Debuggers, turns out, are very complicated. Okay, so what am I testing? I'm just going to run through some manual test cases for myself. So let's see. Run it. Save while running. Restore while running. It seems to have worked. Okay. Run it. Save while running. Stop. Restore while stopped. Seems to have worked. Okay. Run it. It stopped. Save. Continue running. Restore. It seems to have worked. This exception access violation is bothering me, and then sometimes when I F10 after I restore, it crashes, which also will bother me. But it seems to be okay. Like, I'm sure there are bugs in here. We've hit a few of them. But I'm feeling like what I should do is clean this up, write tests for it, submit that, and then attack the bugs as a later task, which is like all I can do to manage the complexity of this thing. So before I do that, I'm going to go back to the debug thread. I'm going to get rid of this. I don't like that it saves off this state right here, as previously discussed. So I'm going to make it not do that. And instead, I'm going to set that at the appropriate spot where calculate stack data is called. So let's see. Send stack data. You know what I might do? I just won't set it at all. I'm gonna be a naughty boy. I won't set it at all. There's like one invocation of this that requires you to set stack data at that, I'm guessing, at that point. And all of the other ones are optional. And I'm thinking if I find that invocation and set it there, then everything will probably be fine. So let's see. How many invocations of calculate stack data do we have? 1, 2, 3, 4. We have 4. So one of these 4 is where I have to do it. Obviously not this one. Probably this one. Send stack data seems like probably where it should be. This one is while you're single stepping. This one is setting checkpoint. Okay, so I'm going to go ahead and assume that this is where I have to do it. I can't even remotely comprehend how that would even work. You literally have to store everything in the assembly or so, and then figure out on the stack where you are and how you progress through the code, more or less. Is it possible to quickly outline the gist? Sorry, the gist of what? Checkpoints in particular, or the debugger in general? The whole idea. Okay, I can give you a quick run through on basically like how is a debugger built? And I'll keep it very quick. Stack data, stack capture. Once I get this out of my head, this should be stacks. Okay. Yeah, so a debugger is enabled through two things. Hardware support and operating system support. And in this case, I'm really only using the Windows operating system API. Wait for debug event, which there's some setup to do that I'm not showing here. You have to create a process that is debuggable, and then call a few other functions basically. But then you call this on the function, wait for debug event and continue debug event. Okay. This, is there like a really, here, writing the debugger's main loop. Here's like a really clear example. Wait for so you've done all the registering stuff. Yeah, this is the main loop of the debugger. Okay, enter debug loop. You wait for debug event, and then any program that I'm registered as currently debugging, it's going to return, like my debugger will be blocked while this function is running. And then when the hosted program runs into some kind of error or breakpoint or anything like that, then this returns, and the event that happened is in this variable right here. And then I have to figure out what I want to do with the event, and then when I'm done, I can tell the operating system to tell to make that program either like if it was an error, should I pass that error onto the program that's being debugged, or should I handle it and hide it? Right? For a breakpoint, what happens is it's actually an artificial error that gets raised in like an artificial interrupt. And then the debugger sees it because it gets returned here in wait for debug event. And then says, actually, no, that wasn't an error. It's just breakpoint. Program should continue going as usual. And so it's these two programs that Windows exposes, taking advantage of the hardware features that enable debugging that let anyone write a debugger. You can write all sorts of really crazy things with just these two features. So that's what I'm using. The details are way more complicated because, like, how do breakpoints work? Turns out you have to patch the process's instructions. Like, there's a memory page with the code. You have to patch that code to add the breakpoint. You have to do that. The way that stepping through code works is, frankly, like really crazy. Source level debugging, like step over, step into, step out, is really complicated, actually. Like, when I had to go build it, I gained a new respect for what Visual Studio is doing. It's actually kind of crazy. But I'm going to skip all that because this was just the simple explanation. And if people want to learn more, they should feel free to ask questions. Okay, so let's go run my tests. All the tests fail. Oh, whew. I thought that test was going to fail. Sometimes failure is not passing. Wow! All the tests passed. Fascinating. Restore checkpoint, single step, restore checkpoint, run. Okay, good. Well, that's encouraging. All my tests pass. I have to write new tests. I should probably write like 4 or 5 new tests for this. Because I just did a fairly significant change to how this thing works. But I'm going to do that after dinner. I'm going to call the stream for now. It's been a great stream. I basically have solved the problem, and people have gotten to see the inside of my debugger. And writing tests is boring. I'm not going to do it on stream. I'm going to do it after stream. I'm going to do it tomorrow or something like that. So, yep, I'm going to call it right here. I'm going to run it one more time because it just feels so janky. I'm not really satisfied with the fact that, yeah, like this thing. What is this thing? What happens if I just F10 past it? Yeah, I'm going to ignore you. Pretend you're not there. What was it confused at then? Is this a it's a const reference to an int32, but it, oh, this is maybe like the value of a pointer that's being displayed as an integer. Oh, this is probably a bug of mine. Oh, I'll bet. Here's what I bet. Yep, it freaks out again. Okay, very good, very good, very good, very good, very good. Okay. Okay, now I'm out of there. Push back. Okay, I'm just going to put a breakpoint here and push back. Step into push back. This is not push back. Oh, this is operator. Okay, let's try again. This also is not push back. This is the exact kind of problem that I want to solve with my debugger. Never stepping into the one that you want to step into. Oh my god. Okay. Great. Then this is a really easy bug to log. There's a certain type or combination of types that makes my type system freak out. And I believe it is a reference to an int32. Reference to int32 underscore t, I believe causes my debugger to freak out. I think I have I have a little test program called types.exe that I would have thought would have had it like it has little tests for all of these things, but I guess I don't have a reference to an int32, arrays, pointers, reference, pointer to int32, void pointer, references, reference to int32, but there's not a const ref to int32. There is const ref to const int32. All right, well, then I'm going to do this. I'm going to make another note. Why does debugging through stud vector? Hold on, I have to. I'm gonna get that breakpoint back so that I can. Okay, let's see here. Not this one, or this one, or this one. This is back. So pushback is the one that offends me. Okay. And int. I've never actually stepped into this function before, so I don't know why it's doing that. This is just int pushback. Cause my debugger to assert. Okay, good. So I have 4 notes of things that I need to check out later off stream, and I will do that later. For now, I will end the stream. Thank you everybody for watching. I appreciate it. As usual, if you ask me any questions, I'm happy to answer them, programming or otherwise. But I don't imagine that debuggers are the most fascinating things to most people, but ever since I started writing this one, I have found it amazing. There are so many cool, like, compilers get all of the glory. Debuggers are just as interesting and complex in good ways. And so anyway, people should have a lot of questions about them, and I'm happy to answer any question that people have. So that will call it for this stream. Since I'm back streaming now, I'm also going to be streaming some video games, including Final Fantasy VII. Thursday, 9 p.m. is when it unlocks. We're going to play the whole thing in the span of, like, basically from Thursday, 9 p.m. until whenever I'm done, probably the whole weekend. I'm going to be playing this one game on stream 24/7. So come hang out and watch that. And I'm going to try and make Tuesday night streaming night as well. So smash that like button. Boom. All right. This was the first programming stream. Yes, you caught the first programming stream since I've been back. But I've done 2 Final Fantasy VII streams also. So